Welcome back, guys. Today we'll be doing a CAPE Unit 2 past paper question coming from the year 2019. It is question 2, which contains partial fractions, integration by substitution, and integration by parts. Let's get started. So this question, we need to determine the integral x to the fifth times cos x cubed dx. Now the x cubed that we have within here, we have to get rid of it. We're going to replace x cubed to be another letter. Let's simplify it with t. Because if I replace x cubed to be t, it becomes cos t, and I know how to integrate that. Now I'm going to differentiate t with respect to x, so I have dt dx, then differentiate x cubed, so I get 3x squared. Now when I do this, it means I'm doing a little bit of substitution to simplify this. So I'm going to cross multiply, so the 3x squared will be in the denominator, so I have dt over 3x squared is equal to dx. Now the next part, now I'll be replacing dx with dt over 3x squared. So rewriting x to the fifth, then remember x cubed is now t, so I'm going to replace x cubed with the letter t, and then dx will be replaced with dt over 3x squared. Now we can cancel x squared into x to the fifth. That will be left with x cubed. Now x cubed, it's the same thing as t. Initially, that's my substitution. So I can replace here with t. So I have the integral of t instead of x cubed, then cos t, and then I have dt over 3. So the 3 is not being cancelled. Now dt over 3, I can rewrite it as 1/3 times dt. So that means here I can rewrite this as the integral of t cos t times 1/3 dt, and I'll put this in my brackets, so the cos t together and then times 1/3 dt. Now I'm going to carry the 1/3. Once you have a constant, you can carry it in front of the integral sign. So here we have to integrate this using by parts, because we still have two functions side by side, but it's simpler. So I'm going to let u to be t. So let u be t, and dv being cos t. So dv being cos t. So the integration by parts, I differentiate this. So du is equal to, just like how you differentiate x to get 1, you differentiate t to get 1. And dv to get v, we have to integrate cos t. So integrating cos t, I will have sine t. So this will give me sine t. Just a reminder, what is the integration by parts formula? It's u dv being integrated is equal to uv minus the integral of v du. That's by parts. That's what we're going to apply. So integrating this, which is 1/3 integral of t cos t, applying the by parts rule, I will substitute what is u, what is v. So I have 1/3, open bracket, my u, which is t, my v, which is sine t, minus, then I have the integral What is my v? My v is sine t, and du is 1. Then I'm integrating with respect to t. Now 1 times sine t is just sine t, so I don't have to write the 1. I could just have the integral of sine t dt. Now, after doing this, we're going to integrate sine t, but before I do that, remember this is within the bracket, 1/3 is outside, so we can distribute the 1/3, so 1/3 times this first bracket, t sine t. Remember that the 1/3 is coming from the question that we were working with. And then we have minus 1/3 integral of sine t dt. So don't forget the 1/3. Now I'm gonna integrate sine t. The integral of sine t is minus cos t. Now this negative sign will affect the minus sign that's in the formula, so there will be a change in sign to be plus. So I have 1/3 t sine t. Then here I will have plus, because negative times negative is positive, 1/3 cos t plus our constant, c or k, whichever one you prefer, or a. Now remember t is x cubed, so don't forget that part that we need to resubstitute. So the final answer is 1/3. Then we have x cubed sine x cubed plus 1/3 cos x cubed plus c. And that's it. The next question that we have here, integral of e to the 2x all over square root of 1 minus e to the 4x. Now the e to the 4x that I have here, I can rewrite it in another form. Now e to the 4x, it is the same thing as e to the 2x all square. So e to the 4x, I can rewrite it, and it's equivalent to e to the 2x all square, and I will be substituting the denominator where I have e to the 4x with the expression that I've expressed there. So by recognition, this is similar to the integral of u prime over square root of 1 minus u square. If you have it in that format, the integral of this will be sine inverse u. So I'm going to rewrite the following integral above so that I can see the following integral below. So let u be e to the 2x. And that means where I have e to the 2x, I can replace it with u. Now before I do that, I need to first manipulate the denominator as I've stated before that I should. So 1 minus e to the 4x is 1 minus e to the 2x all square. So having the following above, I can now see where I need to replace e to the 2x to be u. So doing this, I will have the integral of e to the 2x. Now, e to the 2x in the numerator should be the differential of what I have in the bracket in the denominator. So e to the 2x should be in the numerator 2e to the 2x when I differentiate this. So if I put a 2 here, I have to put a half on the outside to balance it out, because based on the recognition formula, the differential should be in the numerator. So to get that, I have to assign the 2 in front of the e, but I also have to put a half on the outside. So having my half on the outside, I will have 2e to the 2x all over root 1 minus e to the 2x all square. Having it looking like this, it looks like what I have above. As you can see, I have it in the form where you have the derivative in the numerator, and it's a derivative of u, or u is e to the 2x. So just by looking at this, it's exactly by recognition, it's a sine inverse. The integral of this will give us sine inverse. So that means the answer for this is a half sine inverse, and in this case, our u is e to the 2x, and we have our plus c, which is our constant. And that's it. The next question, we're going to use partial fraction to show that the left hand side is the same as the right. So the left hand side, I am first going to rewrite it in another form where I will have to find the unknowns. Here we have a over x, and since it's a repeating quadratic, it's nonlinear, so we're going to have x squared plus 1, and then we're going to have another part that says x squared plus 1 all square. Now, because x squared plus 1 is not like a perfect square where we can factorize, that's why I'm going to have bx plus c. We include a variable. Same case here. X squared plus 1 can't be factorized, so that's why I include dx plus e. So it's not like x plus 1 all square, where we know as a partial fraction, I can rewrite this as a over x plus, then I'll have b over x plus 1, and we know a repeating factor, I'll have c over x plus 1 all square. Now because I have x squared plus 1, it's not able to be factorized, so that's why I have bx. Now I am going to find the LCM. So the LCM for this will be x times x squared plus 1 all square. Now if you're wondering, how is it that I am getting such information, I'm just going to show you. Let me just go ahead. So how did I get x times x squared plus 1 all square? Say for example, I have a half plus 1/3 plus 1 over 9. We know the LCM for this lowest common multiple is 18. And if you realize, we didn't say 2 times 3 times 9, right? So we didn't say 2 times 3 times 9 for this. So the same case here. This would not be the included in the LCM, but the x times the x squared plus 1 all square. Now, what we're going to do now is, how do we find the LCM? First fraction, we say x into the denominator. So x in the denominator gives me this bracket, so I multiply by a. So what I'll have here is a times x squared plus 1 all square plus the next fraction, the denominator into what I have here. This cancels, so I'm just left with x times x squared plus 1 multiplied by the numerator. So I'll have bx plus c multiplied by x times x squared plus 1. So that's what I'll have right here. Then I'll have plus, then x squared plus 1 all square into the denominator. That will cancel. So what I'll have is just x times dx plus e, because the x plus 1 or x squared plus 1 all square goes into the what I have in the denominator. It cancels. So x times dx plus e Now what we say now is that the left is the same as the right. So I can just neglect the denominator and focus on the numerator. So the first thing I need to do is find out what is A. Now to find out what is A, I'm first going to assign x to be a value. So focusing on the numerator, I can assign x to be 0, and I can eliminate quite a number of variables and letters that I have here. So let's x equals 0. So replacing 0 here, I would have 0 plus 1 because 0 to the 4th is 0. Replace here to be 0, so I'll have a times 0 squared plus 1 all square, plus replacing the next part to be 0, I'll have b times 0 plus c 0 times 0 squared plus 1 plus 0 d times 0 plus e 1 equal 0 squared plus 1, that's 1. So 1 squared is 1, so 1 times a is a. Then here b times 0, that's 0. So that's gone. 0 squared is 0 plus 1, that's 1. So 1 times 0 is 0. 0 plus c is a c. So this is c times 0. That's 0 times 1, that's 0. So right here I have 0. D times 0, that's 0. Plus e, that gives me e. So 0 plus e is e. But e times 0, that gives me 0. So here I have a to be 1. So I found what is a. So I need to find out what is b, c, d, and e. So the next thing that I'm going to do is expand the bracket that I have here. Now, if you realize I have 1 there because I found a to be 1. So x squared plus 1 all square. I need to expand this. So we have x squared plus 1 times x squared plus 1. Then multiplying x squared times x squared, that gives me x to the 4th. Then x squared times 1 and 1 times x squared, that will give me 2x squared. And then 1 times 1, that gives me 1. So x squared times x squared, x to the 4th, x squared times 1, and 1 times x squared, that gives me 2x squared when I add them. And then 1 times 1, that's 1. So replacing here, that's what we'll have, x to the 4th plus 2x squared plus 1. Now, to simplify the next part, we are going to multiply 3 items. We have 3 expressions that needs to be multiplied. So here, x times x squared plus 1, so x times x squared, that's x cubed, and then x times 1, that's x. Then this will be multiplied with the next bracket, so bx times x cubed, that is bx to the 4th, and then bx times x, that's bx squared. Then we have c times x cubed, that's cx cubed. So I have plus cx cubed. And c times x, that's cx. X times dx, that is dx squared. And x times e, that gives me plus ex. Now, what I'm going to do is find out what is A, B, and C, D, and E by using the coefficient of the variable. So equating the coefficient of the variable, I will have the coefficient of x cubed. Let's look at the coefficient of x cubed. On my left hand side, there's no x cubed, so we say the coefficient of x cubed on the left is 0 because there's nothing there. On the right hand side, we look for the x cubed, and this is c. The coefficient of x cubed is c. So here I'm able to say c is 0. Now let's look at the coefficient of x squared. So the coefficient of x squared, we have to look at the left and the right. So on the left hand side, there's no x squared. Once there's nothing there, we put 0. And then we're going to look at the coefficient of x squared on the right. So on the right, we have the coefficient of x squared here. I have a 2 going across. You see there's b for the next coefficient of x squared going across again. I'm seeing a d. So we take the coefficient on the left and the right. Now I'm going to carry over the 2, so it becomes minus 2 equal b plus d. Now let's look at the coefficient of x. The coefficient of x, I will look on the left hand side and the right hand side. So the coefficient of x, there's nothing there, so I'll have a 0. And the coefficient of x on the right, so going across, I'm seeing c. So coefficient of x here is c plus, going again, it's e. So I have c plus e, but c is 0. So that means this is gone. So here I know that e is equal to 0. Now the constant here, I will have 1 is equal to 1. So that's not going to help me with finding out. If you guys, I have b, I have e and c, and I have a, but I don't know what is b and what is d. So I didn't use the coefficient of x to the fourth, and order doesn't matter, it's just by coincidence I didn't. So I need to look at the coefficient of x to the fourth, because somebody might be wondering, why is it that I didn't use it? Just a coincidence that I didn't use it at first. I could have started off with it. So the coefficient of x to the fourth, we're going to look on the left. So on the left, I have the coefficient of x to the fourth is 1. So I'm going to write, this is the coefficient of x to the fourth. And also I have a 1 in front of the next x to the fourth. So the coefficient of x to the fourth is 1 on the left. And on the right, I have another 1 plus b, because we have bx to the fourth. Now carrying over the 1, I have 1 minus 1. That is, when I work out that gives me 0. So now I know what is b. I can just eliminate this b. So that tells me d is negative 2. So now I have all the values for the letters a, b, c, and d. So I can go ahead and write out the answer for this partial fraction. So substituting what is a, b, c, d, and e, we know that a is 1, so I'll have 1 over x. And I found b to be, e 0, b 0, and c 0. So using that information, this will be 0, 0. So that means I don't need to use that fraction. D is negative 2, e 0. So therefore I'll have minus 2x, don't have to write the plus 0, all over x squared plus 1 all squared. Now positive times negative, that's negative. So I'll have 1 over x minus 2x over x squared plus 1 all squared. And as you can see, we have gotten the partial fraction which we need to show. Next, we're going to integrate the following, but we're going to use the information that we got in part 1. So we are going to rewrite this fraction as a partial fraction that we actually shown. We were given it already, but we showed that it is indeed correct. So we are going to integrate each of these fractions. Now, the integral of 1 over x is ln x. Now, we are going to integrate this fraction. What we're going to do, we're going to carry the x squared plus 1 raised to the power 2 up to the numerator, so the sign will change, so it will become minus 2. Now we're going to integrate this by recognition. Let's look at the formula. If we have it in this format, where I'm going to have the derivative times the function within the bracket raised to the power n, so the integral of something looking like this will be f of x, and then it will be raised to the power n plus 1 over n plus 1. So once we have it looking at the derivative on the outside, as you can see, I have the derivative, which is the 2x on the outside. So I can integrate this using that formula that I've presented. So we add 1 to the power. So what I'll have here is just x squared plus 1 raised to the minus 2 plus 1. We add a 1 to that. So that's minus 1 over minus 1. Then we have our ln x, and don't forget plus c. Now I can rewrite this in a different form. Now remember, I've just applied this formula where I have the derivative. Once it's the derivative and the f of x within the bracket, then we are going to apply this rule. So don't forget, I'm just applying the rule that once it's in that format, derivative at the front and f of x within, you just add 1 to the power. And when you add 1 to the power, whatever is in the power will be the denominator. So minus 2 plus 1 gives you negative 1. Now negative times negative, that will be positive. So I'll have my ln x plus, because the 2 minus, change it to a positive. You can't forget about the 1. Then to the minus 1 is the same thing as me rewriting this as 1 over x squared plus 1 plus c. And that's it. Thanks for watching, guys. Don't forget to like and subscribe to my channel. Have a great day.